tell people that I try to make code more simple, I sometimes get pushback from people who equate simplicity with junior, beginner, novice, even children. And it is true that when we teach people things, and I teach people things a lot, we start very, very simple. We maybe only put the primrose or happy path, right? We don't need to check our assertions. We don't need to make sure that we've been given a reasonable number. You know, if we're checking to see if something is prime or odd or whatever, we can assume it's greater than 0. If we certainly don't, on day 1 of Intro to C++, write some code that defends against malicious inputs over the internet, right, from people who are trying to hack your server. We might only show half of an algorithm. So if I need to move something around inside a vector, here's how you move it forward or here's how you move it up, but I'm not going to show you how to move it backwards or down. Because I'm keeping it simple, right? Because you're beginners and we're just getting started. And there are good reasons for this. I'm trying to teach you like what the difference is between an int and a double, okay? Or what a string is, or that we have this concept of an if. And I don't want to clutter it up with, actually the code has to be twice as long because sometimes you're moving it backwards. I want to focus on one thing. And that's mostly a gift to the person I'm trying to explain it to so that they can only focus on one thing. If when you took people on day 1 of Intro to C++ and showed them actually industrially appropriate code with tests and assertions and preconditions and postconditions and whatnot, they probably wouldn't come back for day 2. And you know, I'm a Canadian, so I get to quote Marshall McLuhan, the medium really is the message. And when you are choosing a code snippet to put into a slide, that changes what code snippet you choose. That's a very real phenomenon, and it also happens if you're going to write some demo code and bring up an IDE in front of a room full of people. You're not going to do that in 9-point font, and you don't want to have to scroll around. You certainly don't want to have to scroll sideways, so that controls what code sample you choose to show your beginners. And this is all actually a good thing, right? We're trying to make it easy for people who are just learning. So we're all kind of pro-simplicity in that context. That's, of course, a temporary context. We're making up a demo because I want to show you what a vector is. And I'm really focused on what a vector is. As a result, my vector isn't anything. It's called V, because I can't think of a better name for it. Because if I wanted to make a class called exam grade with whatever fields you'd need to have if you were actually writing a system for marking exams, and then have a vector of students, each of whom has an exam grade, I'd have to explain how marking exams work. I don't have time for that. So my vector's called V. And it's probably a vector of ints, because then I don't have to explain anything else. And when I iterate through it, I bet you I call them N or I, because they're integers, and I have Fortran habits around. But that, you know, it's that very artificiality that brings in the simplicity. The functions are all called f and foo because they're not real, and therefore I don't have anything to hang names on. But of course, we all get past day 1 of Intro to C++. We start writing real programs in the real world, and the real world is complicated. And our programs reflect that. And they should. It's not a good idea to leave out all the error checking for simplicity, right? It's not a good idea to only handle positive numbers, or only handle moving things forward, or only handle increasing. Obviously, you have to write the other half of that code. So your code gets bigger, gets twice as big, and then 4 times as big, and then 8 times as big. It gets really big. And it doesn't just get big, it gets complicated. And a lot of the times, we take that as a proof of excellence. It was simple, but now look at it. And we take that inside ourselves, and we say, I'm not a beginner. I'm way past Play-Doh. Life is complicated. My code resembles that, and I'm proud of it. Really proud of it. This simple little wood sculpture, I believe it's the work of a Chinese monk, and it's locked up inside a glass case so that people can't touch it, because whoever made it is really, really happy with it. And we tend to go around and say, look, this was hard to write, it should be hard to read. If it was easy, anybody could do it. And we're pleased at how complicated our code becomes. And I would like you to embrace an entirely different kind of simplicity than the simplicity of day one of Intro to C++. A simplicity that's actually really difficult to get to, that's the opposite of that Baroque wooden sculpture. Simple code is code people can read and that they can understand and that doesn't surprise them. Simple code is transparently expressive. You know, you read it and you say to yourself, so they're going to get set up, process each line, and then clean up. That's the sort of thing you like to tell yourself as you're going through code and you understand it. It's not just understandable, it's actually reassuring. It keeps kind of holding your hand and taking you where you need to go, and you don't feel lost. And you don't have those moments of, wait, what? This does, wait, oh yeah, okay, that's fine, good, oh no, I get it, I can see how you can do that. You know, we can be very proud of those. I don't know how many of you were in the pub yesterday. There was some wait what code in there. And we were very proud of them. There was lots of like, ooh, good one, this minus, I like that. That's okay for that context, but in our actual code that we deploy, you don't want those moments. You want the code to be unsurprising and transparent, for everyone to see what it does, for everyone to understand. And I'm going to tell you that I think that's better. And I'm going to take a little time to try to prove to you that it's better before I launch into how to. But first I have to complain about the word better. You know that when I'm not here, one of the things I spend a fair amount of time on is in the Stack Exchange family of sites. Stack Overflow, and there's sites for travel and getting along at work and those sorts of things. And on Stack Overflow and its siblings, you are not allowed to ask whether one thing is better than another. Travel. Which is better for my vacation? Australia or Sweden? Well, I don't know. Like, Sweden does have a lot less crocodiles. But I don't know what constitutes better for you, right? I don't know what you like to eat. I don't know what kind of adventures you like to go on. I can't answer the question. If you want to ask me which one is closer to England, I got it. I can answer that question, right? You have to explain your criteria for better. So I trotted out some potential criteria for better if I'm going to tell you that writing simple code is a better thing to do. Would it be faster for you to write lines of code per day? You know, when I was first writing software for money, which I've been doing since 1979, this shocking statistic came out that most professional programmers averaged over the course of the year about 5 lines of code per day. Mostly because I think we just write the same line over and over for weeks on end. And it really hasn't changed much. We spend time testing, we spend time on requirements, and we do spend time debugging and writing that line again and again. So how much longer is your program at the end of a year divided by how many days you worked? You probably won't be far from 5. This approach isn't going to get you faster, but maybe it'll get you more correct, or more performant, or easier to modify. Or, and this last bullet's a little bit controversial, but to me this is perfectly legitimate, more fun. You are actually allowed to enjoy your job. They don't come along and take some of the pay back if it turns out you're having a good time. You can keep it a secret if you want to, but you know, enjoying creating something, looking over it and going, I like that I made that, is actually a very pleasant way to spend your days, and I want to advocate for that as one of the motivations for writing this way. So, first the bad news. It's not faster to write simple code. This little piece of wooden sculpture isn't something that was knocked out in 5 minutes while waiting for a conference call to start. You know, it's much simpler to understand than the Baroque monk creation, but it wasn't necessarily a 5-minute job. There's a quote about apologizing that the letter is so long because I didn't have time to write you a shorter one. And when I was prepping the talk, I got to figure out who wrote this. I hate unattributed quotes, you know. Use the force, Harry, dash Gandalf, you know, with a picture of Jean-Luc Picard or something. So I'm like, okay, who wrote this quote? Well, Blaise Pascal comes up a lot. Samuel Johnson comes up a lot. On American sites, there's an awful lot of Mark Twain action. So I think you just pick it according to your country. So as a Canadian, I have to tell you that it was Margaret Atwood who said, I apologize, I've written you such a long letter. Whoever it was, it's a valid point. It takes time to be concise and to take away all the extra words and all of that. You need to build up some new habits so that you write differently and that you look over what you've written and come back and revise it and say, it's right in that it works. I've even stepped through it with the debugger and it gets the correct answer, yay. But now I realize that I could have done something simpler now that I really know what the problem was. And I'm going to take the time, even though it technically works, to make it simpler before I say I'm done. It would be worth it though, right, if you gained something from it. And my experience going into places and fixing up their code for them is that when you make code simpler, you generally make it more correct. Simple example, if you embrace the horribly named, but we couldn't live without it, RAII, the, oh yeah, sometimes we don't clean that up bug goes away. I told a long story at Meeting C++ about RAIIing a thing and getting rid of a bug that had existed for decades because sometimes things weren't cleaned up when one particular combination of errors and exceptions occurred. Once that cleanup is in destructors, you know, the objects inexorably go out of scope. They just do. You don't have to remember. And therefore you cannot forget, and therefore your program gets more correct. When the true path through your system is lying there easy to see and expressive because it's not obscured with a bunch of unrelated housekeeping code, oh wait, no, when it's negative we have to do something. It shows itself to you. So generally speaking, simpler code is likely to be more correct. That doesn't mean that your Play-Doh code that you first write that assumes everything's positive and blah, blah, blah is magically correct. But when you have something that's mostly right and then you actively simplify it, there's a good chance it will then come completely right. And there's the matter of time. You know, Lisa was talking about programs in space and programs in time. And you write your program now, and you give it to the world, and it then goes forward from this point on. And people change it. So if you have a spot in your program where you have 3 somethings, blocks of code, functions, whatever, and later someone's going to have to make a change, they have to remember to change all 3 places. This is a bug waiting to happen, right? Especially if it's not 3, it's 11. Or 18, been there, because someone does 17 out of 18 one day. And those are the really hard to repro bugs where it literally matters whether the person pressed escape or clicked on the X. If you take away today an opportunity to be inconsistent later, your program will stay correct. If you write in there the 3 or the 11 or the 18 things because copying and pasting is simple, then in the future, someone has to remember to change it in all those places. And there are lots of different ways to be inconsistent. One is to have, 5 different overloads of essentially the same function, where you've copied and pasted the body and made some little edits. Someone's going to have to change every overload. But there's also just the concept of a function. Someone takes these 10 lines and copies them from here and pastes them in here and edits them a bit, and they're really kind of the same thing, but they're not even labeled as being a function. They're just some lines in the middle of some bigger thing. So even the act of simply writing a function is taking away an opportunity to be inconsistent. And if you have a number of very, very similar functions, but what they differ in is like what types they work with, then maybe taking the time to write a template is how you take away that opportunity to be inconsistent. But all of these things keep your program more correct a year from now than it would be if you just wrote a flat, undifferentiated mess and expected people to make all the consistent changes. The other thing I've noticed over the years, I'll bring abstractions into a system really as a way of understanding it. I'll sit with someone and I'll go through some code and I'll identify 4 or 5 variables that are clearly related, sometimes because their names all start with the same string. It's very common. But other times because they're being passed together always. And I'll say, what do these things represent? And eventually someone will say, oh, that's a connection, or that's a request, or that's an order. And then if I write a class that's called connection or request or order, everything gets simpler. You know, because maybe I just passed the connection in, or maybe this is a member function on connection, whatever. But when I've finished, I didn't move the complexity because it's gone. You know, some stuff's gone into the destructor, like if we've got a connection, you all know what the destructor of the connection is going to do, right? It's going to close the connection. And you look up and it's like I was peeling an onion, but I didn't get to a core. The complexity has just disappeared somehow. And that is a thing that genuinely happens. Also want to advocate, not for the first time, for library code. Library code is generally more correct than your code, right? If you've ever done, going back to your intro to C++, you know, the operator overload for assignment operator. And you write it looks pretty good, you know. This points to x is equal to other dot x, all that stuff. And then someone comes along and says, what if you're assigning to yourself? Oh, I didn't check for self-assignment. Right? Or I didn't check for self-swap, or I didn't check for this, I didn't check for that. And the people who write the libraries, that's what they do. They check for self-assignment. They check for what if this is null, what if that's left out, what if the thing you think is more is actually less. So generally, their code is more correct than your first pass. So the more you embrace library code, the more correctness you will end up with. What about performance? I wish I could tell you that the simple, transparent, obvious, expressive code is always going to be faster than the opaque and complicated code. But it's not. Right? I'm just going to write a ranged for, so clearly this is modern and wonderful. But it matters how I declare that loop variable. If I declare it as a reference, we're saving a copy, which may or may not be relevant depending on what a person is. If a person's 3 ints, it doesn't matter. But let's pretend a person is big. In order to know that I need to add the extra little piece of punctuation, there's not like a paperclip that jumps up that says it looks like you're copying in a tight loop. You have to know some things, right? You have to know how ranged fors work. You have to know what copy costs. You have to know how big a person is. And you have to know the magic piece of punctuation to add to your code to not get a copy. And then the consequences that if you change P in the body of the loop, you're changing the real thing in the collection and blah, blah. You have to know all of that. And worse than having to know it is it has to properly present itself to you in that moment. I'm sure you've been talking to someone when they say that they have to do something, yada, blah, 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 Wednesday, da, 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 and you're like, well, today is Wednesday. And they go insane, and they rush off because they knew their thing was Wednesday, but they didn't know on Wednesday that Wednesday was Wednesday. And so you have to, while you're writing this loop, remember about the cost of a copy and remember how to suppress a copy. That takes knowledge and ability, and it produces code that's not as simple, but more performant. I'm never going to advocate for simple over performance, but I will add this really important caveat, which is if a real choice exists. If your person is 2 integers, why are you cluttering up my brain with extra punctuation suppressing copies? Right? If you have a performance issue, code to your performance issue. I was telling someone this story the other night about a startup I worked on, 2 men and me, so that's a great combination. When it all fell apart, the other man bought a bright red sports car for a very large amount of money. I think he was deeply hurt by the falling apart of the startup. But at one point, the code as a whole would not build. They had all this code that people were typing in, but you couldn't compile. You could compile some files, but you couldn't build the whole thing. And he showed me a particular routine that he was very proud of. He said, I have rewritten this 20 times to make it faster. It had never run. It had never even been compiled. But he knew that he had to rewrite it to make it faster, and that he was proud of how much faster it was, you know, by looking at it. How it contributed to the overall perf of the application was, of course, an utter and total mystery. You have to know the choice exists before you can say, I'm going to choose performance. You don't just rewrite it to make it faster in the beginning. And remember, again, talking about libraries, that code is probably faster than what you would write. You know, if you need to move something around in a vector, the naive thing to do is to insert a new space, move everybody down, put the thing you want in, move everybody up, close up. But you don't actually need to do that, right? There are faster ways to do it, especially if you're just moving a short distance in the middle of a really long vector. There are ways to do it where you leave the tail alone and only mess around in the area you're messing around in. And people who write libraries have gone and had that conversation, and you might not have. And if you get a chance to watch Matt Godbolt's CPPCon talk from 2017 about what has my compiler done for me, this adorable faux frustration, but it's probably born from a real experience of writing more and more helpful code and having the compiler with optimization turned on continue to produce exactly the same assembly language. So you start with really transparent and obvious and understandable code, but it's so naively simple, ha ha ha, we can unroll this and we can hoist that and la la la. No matter what you do, you keep getting the same assembly. Because whatever you can think about say hoisting something out of a loop, the compiler can do that too. And they are maybe better than you. They're guaranteed to be better than you if you're not measuring. Okay? If you're not measuring, they will beat you. Now, Marshall's going to argue.
No, I'm not going to argue. Absolutely. At this point, usually in one of my talks, I will quote Lord Kelvin, who says, you know, if you cannot express your knowledge in terms of numbers, then your knowledge is of a meager and unsatisfactory kind.
A meager and unsatisfactory kind, if your knowledge has no numbers in it. I like it.
But the other thing is that I will regularly get people who say, yeah, this is really slow, and here's a sample code, and here's my output. Oh, yeah, I compiled it in 0.
Right, or in debug. I compiled this in debug, and it's super slow. That's nice. Yeah. That's a useful thing for me to know. Thank you for sharing. So if you haven't measured, then you are not choosing simplicity versus performance because you don't know anything about your performance, right? But you today, why would you want to write simple code? This is the only picture that I didn't source off the internet. I took this picture. This is my canoe. And I built it 32, 33 years ago. And it still works great. Canoe is a great example of a simple structure. It literally has no moving parts. So there's nothing to wear out or to need oiling or whatnot. And it works wonderfully. It takes me across lakes to islands where I can get away from the riffraff. So when you write simple code, you can see what it's supposed to do, compare it to what you think it's supposed to do, and debug it when it's not working. You will probably be less frustrated if you always write simple code. We've all had that experience just a week later of coming back and saying, how did this ever work? Why did I think this worked, right? Because we've written something that even we don't really understand. When your code doesn't surprise you now, it will also not surprise you in a month or in a year. And whether you're maintaining it in a month or a year, or whether the person has your email address, you know, they both work the same way. You don't want there to be any kind of a, I have no idea what this does moment. You want simple, reassuring, plain, accessible code. And I find that when my code expresses my intent, I feel all lined up. What I'm typing, what I'm reading, what I'm thinking, it's all the same words. They connect. There's no like impedance mismatch between the picture in my head and what my fingers have to type. That is a more pleasant state in which to spend your days. And since most of us do spend a lot of time reading and writing code, why not enjoy it? But the other reason for the canoe picture is this. If you're sitting close enough, you can see that it's made out of strips of wood. These are 1/4-inch thick strips of cedar. You put them over a mold, which itself is just pieces of plywood. and then you sand them, spoke shave them, make them smooth, make them beautiful. Some gorgeous curves that can only happen with thin strips of wood. And I told you I made the canoe. One time a C++ person, it had to be a C++ person, they saw this picture and they said, "Did you rip the wood into the strips?" I did not. Okay, I went to the wood store, like some common peasant, and I bought strips of wood. And then I made this gorgeous thing. And I love it, and I say I made it, and I don't care that I didn't rip the wood. I didn't grow the tree either, you know? I'd like to make a canoe in 30 years, so I'm gonna plant this now.
That's funny.
I made this tree, this canoe. And you can make beautiful programs out of other people's code. Now, sometimes people say that other people's code is beautiful because you don't have to write it. I want to get away from that. Other people's code can just be beautiful. It's a hard concept. Think about it for a while. It's like other people's babies. Of course, your baby is the most beautiful baby that ever was. I know that. Have you seen my granddaughter? I'll show you granddaughter pictures. But there are other beautiful babies. For example, my granddaughter. I will show you pictures. You will have to agree. She's beautiful. Other people's code can be beautiful. In and of itself, you are not the only person on the planet who can make beautiful, wonderful code. When you totally, really bring that into your bones, you'll be willing to use other people's code. So then its beauty isn't in what it saved you. It just has its own beauty. It really, truly does. You're not the only one who can make beautiful code. So I mentioned that I go in. Often I join projects that are in trouble. Sometimes I come to companies that are teetering on a knife edge. They have a 20 or 30-year-old product that is their entire business, and the guy is leaving. We need someone who can understand this code, explain it to the rest of us, and maybe you could fix up a few things while you're here. I do that a lot. And I like doing that, by the way, so if you need that, we can talk. But I'll tell you what I've learned doing that. This kind of simplicity is really hard. It is easy as pie to skip the error checking. It is easy to only do half the algorithm and not even think about the other half until someone says, what if it's negative? But it is really hard to get where I want you to be. Oh boy, do you have to know stuff, okay? You have to know your language, you have to know your tools, and you have to know our idioms. We have ways of doing things. How many of you have worked with a non-C++ programmer who writes something like, bool retval equals false. If thing, retval equals true. Else, retval equals false, return retval. Right? It's not wrong. And I'm sure we can check on Godbolt, but I'm pretty sure we're going to get the exact same assembler as if I would just write return whatever the condition was. But as an idiom in C++, we go return x is greater than 2 or whatever the condition is, right? That's what we do, that's our idiom. And we are drowning in idioms and making new ones all the time. You can't simplify by using idioms you don't know. So you have to know them. This is a totally different kind of simplicity, right? This is the simplicity of carefully polishing away all the excess until you have something that's expressive and obvious and reassuring, and that's way more work than splatting stuff out and putting in extra things as you think of them and then saying, well, it compiles, so it must be right. So how do you do it? Yeah, my speaker notes, I can't see my speaker notes because of the tech thing, but my speaker notes for this slide say, blah, ha, 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 ha. We will start with some actual, relatively simple things that you can do. You need to know what simple looks like. You need to be able to say, now that I did that, it's simpler, or now that I did that, it's more complicated. That's what you're going to test everything you do against. And you're going to try to be simple from the get-go. But it will grow. It will twist. You will toss a couple ifs in. You will realize you need to loop. You'll decide you have too many ifs and maybe it should be a switch. You need to catch yourself, see what you need to do to make it simpler. And you need to avoid introducing those opportunities to be inconsistent. At first glance, it appears to be a picture of Lego, but it's not. This is Lego Duplo Interop. That's an important thing that came from planning and design. The 2x2 and the 2x4 Duplo are exactly the same in one of their dimensions, but as well, it all lines up so you can put the Lego on it. And that kind of architectural planning and consistency, you got to do that. Some practical things. Names are good. There's a saying that a consultant is someone who will borrow your watch to tell you what time it is. Here's how you borrow a watch. Here's some code. You guys read this code? It's pretty simple, pretty expressive. It's got a comment. I don't care for the phrase code smell. I find it a little, like a poo joke, But some people say comments are a code smell. And here, we have to explain this very, very simple loop because we have the brilliant variable name of I, because it's an integer. How about we do this? Now, what have I done? I've replaced the loop with something from the standard library, namely accumulate. Now, accumulate is a lot more letters than plus, but if everybody on the team knows what accumulate is, they don't need to read the loop and understand the loop. They know it's going to add up all the numbers in the collection. The 0 hanging out on the end of accumulate is the same as the 0 in int I equals 0. It's your starting point. And then I took the radical step of calling the total total instead of calling it I and putting a comment in front of it to say what it is. This is borrowing your watch, right? Total came out of the comments, and this happens all the time. I will see comments that tell me what D is, and I will change the name of D to be whatever the comment said it was, and everyone will be like, wow, this code is so much more readable. Variable names. Especially for old projects have often been started by former C programmers. And you know how you can spot the former C programmers? They declare everything at the top of the function. And up at the top of the function, you don't really remember what it was going to be for. So you got int AXI, double D1, D2, D3, and then when we get down to where we need some doubles, we'll have some. And I went through this whole thing where I was taking notes about what things were, and this is true. I discovered that A was the yearly amount of something, and that I was the change in that something. And I found out later, it suddenly hit me one day, no, A is the annual amount of that, not the yearly. And I is not the change, it's the increase. So the programmer was actually giving expressive names. I would say vowels are free, but both A and I are vowels, so maybe I should say consonants are free. Letters are generally free. Please give your variables real names. And one of the big benefits of calling a function is that the function has a name. Whether it's yours or whether it's something from algorithm. If you say comment sort the collection, then you have your own implementation of, I don't know, bubble sort or something. Or if you just call sort, even if it's your own sort, I don't care. The comment is no longer necessary because the name of the function tells you what's going on. And when I teach algorithms, and I say, so you want to find something, maybe we could use this function called find. You want to count things, maybe we could use this function called count. And sort of light bulbs go off on people's heads. If what this piece of code does is that it updates the totals, then have a function called update totals. And then everyone can see that you're updating the totals.
I just have to say, I totally agree with having function names be mnemonic of what you're trying to do so that when you see the function name, it conjures up something so you have a clue and you can remember that you once read the documentation. But there are boundary conditions and there are subtleties that can't be expressed in a name, or if it can, the name gets very long. So if you have a stable sort, or if you have 5 parameters because you have to.
Yes.
And there are special cases, and we talked about this last night, where an expert programmer can, yes, I know the answer. But anybody short of an expert programmer will have questions and be unsure. The documentation in the interface, not in the code, which
Right.
is different, is essential for testing.
Yes, you are completely right that while a name is necessary, it is not always sufficient. That if you make the name long enough to include all the caveats and don't pass 0 to me and only if positive and so on, it's not a readable name, right? So a piece of code that's just sitting there, 20 lines of code, has no name. You can definitely improve on that, but it's not a continually increasing returns. So to have a 10-character name is better than not to have a name, but to have a 100-character name is not helping. And as John points out, the name alone isn't going to tell everybody everything they want to know. But when it's not a function and it's just sitting there, it doesn't even have a name. And so this is a way to give something a name, is to put it in a function. And no magic numbers, please. Even 0, even -1, but especially 7 and 11 and whatnot. Make some enums. Set up some constants. I would even forgive you for macros if it took you away from magic numbers. And I want your functions to be short, but not so you can print them. When's the last time you, say, this year, printed some code? Only the front row, which I think is all you need to know about the front row. The last time I printed some code, it was the code that I talked about adding RAII to. That was 7 or 8 pages printed with multiple catch statements and multiple go-tos in the catch statements. Yeah. And 3 nested loops, each of which were while true. Now you got out of them with exceptions and breaks and things. Yeah. And I printed that. And I got colors, a highlighter, and I colored like the first go-to label pink, and then I found all the places that go to that, and I highlighted them pink, and it took me a really long time. But I had to because it was complicated. And when I was finished, I didn't need to print it anymore because it was really obvious. Each of the loops had their actual condition, like while tries is less than limit, and that kind of thing. Whereas before, it was just while true, and then when you had a problem, the catch would say, well, if tries is greater than limit, go to exit, that kind of thing. Blah. So that's not why I want your functions short. Not so you can print them, but because a short function probably has one name. If you can't come up with a good name for it because it's doing 2 completely orthogonal things, then it's probably 2 separate functions that can each have a name. I have no problem with update and print, save and new, that kind of stuff, but if you really can't name it, perhaps it's because it's not really an it.
I have to ask one more question because it's the only time it's going to come up. Sometimes people want to print code, sometimes people never want to print code. What is your position? And I know that having reformatting tools is the answer, but if you're not allowed a reformatting tool,
right?
Do you have line limits or not?
Do I have line length limits? I do. But it's not about printing. It's about sideways scrolling, which is gross. And I almost never print code, but I paste code into emails, I paste code into Skypes and chats, and people don't like to sideways scroll.
Do you ever do side-by-side comparison for diffs?
Diffs, another thing too. So really 60 is probably, depending on your screen size, if you're going to have tool Chrome, diff 1, diff 2, and more tool Chrome, 60 is probably a comfortable limit. That's a habit that was beaten into me while I was writing for books, so I pretty much naturally do it. But yeah.
Originally started with printing.
Started with printing. But there's still good reasons for keeping line length limits, absolutely.
So if you ask Chandler Carruth, it's 80 and there's no discussion. And if you ask me, it's 79 for the public.
79.
But for me personally, because I can't spell, it's 78, so if I miss a letter, I can add it and it still doesn't overflow 78.
Well, then I'm very strict because I'm happy at around the 60 mark. But it is, I don't know why Chandler has an opinion, because he's got his magic demo where he flows everything around. It could be 150, it doesn't matter.
You won't discuss it. 80 is the right answer, period, full stop, go away.
All right. The shortest function is the function you don't write. Does anybody know how many lines find if is in accumulate? Who didn't write one? Nobody else, right? As far as I know, that's 0 lines long. because it's not my problem. Like, how long is it?
What, find if?
Find if.
The actual code between the braces, maybe 3 lines.
3 lines. What's the longest one in there?
Oh.
Maybe stable sort?
Stable sort, probably. Stable sort is broken up into a bunch of things.
Yeah. Yeah, well, I'm pretty sure all of algorithm only exists so you can implement stable sort, actually. That's close.
Close enough. There's 6 sorting algorithms, and
Yeah.
they all kind of work together.
They all work together. And they could be hundreds of lines. It doesn't matter. We just say sort, and the magic happens. And so they're emotionally short because they're not our problem, right? They're out of our sphere of concern. Parameter lists, 5. Oh, how I wish that 5 was a lot of parameters, John. I just retweeted someone who said, this morning on Twitter, they said they just found a constructor that takes 53 strings. Yeah. Okay, so then that's my world. Abstraction is totally the way out of this problem. Let's say we were just being crazy and having 4 integers. The problem with 53 strings or 4 integers is they have no semantic meaning, right? So is this like x1, y1, x2, y2? Is it x1, y1 height, width? Is it x1, x2, y1, y2? You do not know. Don't start me on source and destination. Like, where you can, abstracting things so you don't take 4 integers, you take a rectangle or you take 2 points. You want to take 6 points, then I think we need to talk and you need another abstraction. They might be generic like rectangle or point, or they might be specific to your universe, like when I get someone to tell me that these 5 variables that all start C-O-N-N really describe a connection. Let's invent that abstraction of being a connection. That's going to have a lot of benefit. The immediate driver was how can I reduce the number of parameters to this function, but you'll have all these other benefits because, again, you're lowering people's cognitive burden. They don't need to remember what constitutes a connection anymore. They just remember that it's a connection.
You have too many good slides, and I have to say one more thing. I totally agree with this, but, and this is a problem, because if somebody follows your advice, they can actually take it too far. Imagine you have a large object that's well understood like a calendar.
Yes.
And then you have something like a name or a locale or something else that's very small. And you say, what if I compose the two?
Sure.
The problem is that now I have functions that take calendars, and I have functions that take calendars with a locale, and I have functions that take calendars with a name. And now I want to compose the calendar with the locale and the calendar with the name in another function, and I'm stuck and I have to make a copy, and I'm a dead man.
Well, not only that, but in people's heads there's 7 kinds of calendars now, right? So you can take all of this too far, right? Abstraction is your friend, but actually I have a slide for you in a moment.
Excellent.
The other thing is, again, thinking about splitting up functions. Sometimes the reason the function takes so many parameters, like the top third of the function uses about a third of the parameters, and then it's done, and it independently doesn't interact with the middle third, which uses the next clump of the parameters, and so on. And if you just break these up into 3 functions and pass each one only what they need. Or maybe this should be a member function. So in the case of the connection, you've got something that takes 5 parameters all related to the connection. It sounds like it's a member function of a connection class. I apologize for the font, but that's kind of the point. I'll read the code to you. This is a member function called calculate of a class called order. It takes 2 doubles. And we have to make sure that x is less than the limit. Limit must be some member variable that wasn't passed in. We have to make sure that y is not a negative number, that it's greater than or equal to 0. And we have to make sure that we're shipping. And if we are shipping and all those other conditions have been met, we actually do some work, which I can't fit on the slide. I can barely fit this on the slide. And then our Boolean function returns true. I successfully calculated. And the rest of the slide is nothing but else's. And it's kind of a challenge to connect the error messages to the conditions, right? This is the exact same stuff. All that's missing is some braces and else's. You will notice the font is much larger. I flipped the conditions. Right? So it was if x is less than the limit we can proceed, now it's if x is greater than or equal to the limit we have a problem. And in my particular case, the error messages happen to perfectly match the conditions. I wrote them as what the problem was. And now the conditions also say what the problem is. Whereas here, it's the other way around. If the x is less than the limit, else x is too large. So there's some mental flipping that I think is a lower burden here. That's because I'm writing error codes. If you were expressing them as preconditions, you'd be flipping the preconditions in these ifs. Most importantly, each condition is right next to its error message, and the good stuff is much closer to the margin. Right? Once you get past the preconditions, and let's face it, 3 years from now, someone reading this function go, yeah, preconditions. What does it do? They'll get straight to what does it do. It's all right there. Now, when I was taught in 1977 structured programming with What5S at the University of Waterloo, where they'd had What4, so that was Waterloo Fortran, and then when they needed the next release, it was What5. And What5S was structured, and we were taught you must never return in the middle of a function. It was like the wickedest thing you could do, and that was wrong. Returning in the middle of the function is the best thing we can do right here. So if any of these conditions don't meet, we're out. That's a very simple way to make your code much more expressive. I have a question at the back about that. No, that's not a global. That's like a member variable of order. Yeah, please. Do I think globals are a good idea? Generally, no. I'm going to talk about globals in a couple minutes. Probably I would use a more complex return type than bool. Yes, but we're back to the Play-Doh. I'm only showing one thing at a time on the slide. Yeah. Kevlin.
This is, of course, wrong.
Thank you, darling.
Okay, that's cool. My talk yesterday, you just gave me advice in terms of Fortran. One of the things that I highlighted in my talk was that the Fortran advice was correct because C++ and C mess up the concept of a return. Because in C++, C, JavaScript, etc., the return has two jobs. It fails to seek responsibility for it. One, it yields a result from the function. Two, it changes the control flow. That's two jobs. In Fortran, return only does one of those. Now, if you rewrite this with else, then it becomes structured.
Yes, this is the more structured approach.
No. You rewrite it else if, like you would in Fortran, it actually becomes structured, and you no longer have the problem where it returns, and it's a simple transformation. The advice in Fortran is different because it's a different language.
Because it's a different language. That's fair enough. And
so my talk, I spent about 50 minutes yesterday showing why this is not structured, and the structured version involves...
The structured version would be good. Well, I've worked with plenty of people who are writing Fortran in C++. Actually,
I'm not about to advocate Fortran. Everything else about it is utterly horrendous. I was paid to write Fortran. I'm never going to do it again, except for the talk yesterday. But I want to highlight that there is a shift in how the advice is...
right, so that was good advice for Fortran, but it's not good advice for C++.
Oh, it's still good advice for C++.
No, I'm an early return advocate. All right, that's fair enough. We will take that in by absorption. Yes.
I can save some peace here and put you guys together, because there is something in between that gets what you want and gets what Kevin wants. What it doesn't give us is the return optimizations and such for named return optimization. But that's okay, because optimization is secondary.
Optimization is secondary,
right.
yes.
What you want to do is have the bathtub curve. First thing you want to do is figure out, am I the right function for you? And if the answer is no, get out. There comes a point where we decide we are the right function, and then an early return is saved by RAII, but it doesn't mean that human beings are going to see the RAII. So what we do in our code base is, if you have a return that's early, adjacent to the 79 character limit, there is a comment with capital letters that says return, so the human being goes, oh, here's an exit point. It's just for the human being, so they can reason about the code quickly.
So that's a really nice compromise, that these are not unexpected returns because we're checking preconditions and we're bailing. But what John is advocating, and I'm going to support it, I agree it, that an early return in the middle of whatever this comment is substituting for is a different level of surprise, a different wait what. It's fine to bail if you don't meet the preconditions, but once we start into the meat and potatoes of what are we doing, we're calculating an order, early returns there may carry an element of surprise, and we don't want to surprise people. So the minimum comment and explain why you're doing it. Yeah. But to simply say as a rule, I worked for someone who had maximum length for functions and also a required set of comments at the start of a function, and what, like one comment for every variable that you used and what it meant. And so if you had like 4 or 5 variables, you had 15 lines of comments because you had to say this function calculates the order, but it was usually all boilerplate and no meaning. We were left with like 10 lines for the actual code. And what we did then was if we needed 30 lines, we would write calc 1, calc 2, and calc 3, and some other function would call them sequentially. How is that helping anyone? I don't know. So none of this is hard and fast and something that a guidelines checker would check for you. But these are ways to make your code make sense to people. I'm also a const all the things person. If you haven't met a const all the things person, and that's separate from being an East const person, obviously your programs have to be const correct. You have to do that. I'm not going to play chase the const later when I come in and I try to pass a literal to something and it doesn't work, so I mark that takes it by const ref, and then that doesn't work, so I got to change all the member functions. This is a different thing. This is like literally I have a bunch of local variables, int I equals 10, and I'm going to mark that as being const. Mark everything const unless the compiler says I can't. And it feels like work. Why am I typing 5 extra characters, 6 with the space, for no reason? And it's about lowering that cognitive burden for whoever is reading your code. Right? There's 10 variables here, but not really because 8 of them don't vary. And that means when I'm trying to understand why this code is misbehaving or what it's doing, I kind of only have to pay attention to the ones that vary. And this makes me advocate against outparams, and I know that's going to make John argue with me, but we did that last night.
I have to argue with the previous one. If your function is one line and your interface says int, doesn't say const int in the interface.
Yes.
Are you really going to put a const in the one-liner that returns whatever?
That puts it in? Well, I'm probably going to auto, but maybe. The thing is that it means, first of all, it prevents thinkos. If you didn't intend to ever change it again, but someone comes along later and changes it, you get this alert of a cognitive dissonance. And secondly, that when you're just reading through them all, this is the one that changes. I'm going to pay attention as I'm reading. That's the motivation. It's a debugging technique, really. And that's also, yes?
Yeah, sorry. I get what to avoid out params, but I don't quite get what to avoid in out params, and what you want to replace them with.
So the reason I don't like out params and in-out params is again about surprise, and this is probably because I work with a number of people who come from other languages where those are marked at the calling site. And when they're not marked at the calling site, some people are confused that after they call f at a comma b, b is different than it once was. And especially this year, 2018, standing where we are, where we have things like optional, we have things like expected, help us, we have tuple, there are ways to return multiple values, even though you can only return one thing. And usually, when you force yourself through that process, you end up revealing more information about your system. That is, if I take 7 integers, 4 of which I change, what the heck do I do? But if I take a connection and a payload, and I also return a payload, you know more about this function now, and I just made it up while I was standing here, right? Or I return the connection, or I don't know what. So there's just becomes information in the signature. I'm not saying outparams are always wrong, but they can be surprising, and trying to work around them generally causes you to invent some sort of an abstraction, like, oh yeah, I return an optional whatever, rather than I return a bool and an error, which you're correctly objecting to. So there's just a little bit more information, okay? But also that when I say we've got to const all the things, people are like, no, because I need to pass it to this function. And I'm like, but maybe you shouldn't be doing that either. Like, that's not a reason for not consting all the things. So speaking of it being 2018 and us having things available to us, it's not good enough to say that I learned C++. Whenever I learned it, I could do a decade survey, but I won't. You need to know what's been added lately. I did this talk at CPPCon about the guidelines and why const casting is bad, and I walked through a caching example and showed how to use mutable, and on Twitter afterwards, a significant number of people said, this mutable thing seems pretty cool. When was that added? I have a 24-year-old child who is younger than mutable. In fact, mutable is older than const cast. So I don't know how that happened. We had mutable, but we needed to add const cast. So you have to keep up with the language. Stuff gets added. Example, mutable. Some other things too, you know, like we have ranged fors. They're more expressive. It's not really hard, exhausting, bore your watch work for me to go, and we go from 0, less than the size, we increment it here. There's no other increments, there's no decrements. Don't you hate those loops that go back and do one again? And it takes me like a minute, then I know this loop touches every element in the collection. But if you used a ranged for, it wouldn't have taken me a minute. So if you haven't gotten around to doing ranged fors yet, look into them. In the wait what department, we have the private constructor, the private copy constructor, that kind of thing. Sometimes that's legit. Like singleton involves a private constructor which is actually called, right, from the get instance method. But a lot of times, we're only making those things private so people can't call them, or to prevent the compiler from generating something else. That's my favorite, right? I wrote this constructor which you're not allowed to use because that way the compiler won't generate a default constructor. It's a thing that people do. Don't do that. If you would like people not to be able to call a function and a constructor, delete it. It's the thing, we added it. Slightly newer than mutable. Non-static member initializers. Mostly discovered accidentally by people from other languages, in my experience. You know, they're declaring their class, and they put some member variable, and then they say equals 0, and then it compiles, and they say, hey, wait, I didn't think I was allowed to do that. No, you're allowed to do that. And it has some big advantages, because especially if you have a class with a whack ton of constructors, over time, the values to which things are defaulted can branch. So if you use the default constructor, x will be -1, but if you use the one argument constructor, which doesn't take a parameter for x, x will be 0. And if you use the 3 argument constructor, which for some reason still doesn't take a value for x, x will be -1. If you use a non-static member initializer, we can all decide once and for all what the default value of x is going to be. And see, I have a library guy right in the front row. I put this slide for you. Libraries are wonderful. That's why it doesn't say keep up with the language, right? Because the libraries are also changing. I have a friend who worked for a long time with a guy called Rico Mariani at Microsoft, and Rico had this saying about the pit of success. And I was in the management talk yesterday, and it's a management concept. It's the idea of setting things up so that if your people do the most obvious, let's even say lazy, default, boring thing they can possibly do, they will succeed. You want them to fall into the pit of success. And you can do that for whoever takes over your code base, right? You are leaving defaults for these people. So I've talked about taking away opportunities to be inconsistent. When you leave behind 5 very similar functions, and whoever makes a change to one has to change the other 4, their life will be more difficult than if there's only one version of the function and they never noticed what happened. They just do the obvious thing. They come in, they change the function, and the code works in all the weird little cases. If you use non-static member initializers, the constructors can't do that diverging thing. People don't notice when you set this up for them. While they're tumbling into the pit of success, they're not like, who dug this wonderful pit? They think they're great, but that's okay. Using RAII properly and putting the cleanup in the destructor, life is just going to work even when they do early returns, even when they start to live in a world of exceptions, whatever. They don't have to remember to clean up. If you're already const correct, nobody plays chase the const later. And if you give things good names, they're not going to come along and add an I or an X or an A. You know, the line of code I have in mind that declares all the doubles, D1, D2, D3, over the decades, people just come along and go comma D4, comma D5, comma D6, because that's what we do in this function. Apparently, we just assign sequential doubles as we need them. But if they're called income, expenses, profit, then when you need to add interest, you're going to call it interest and not D7. So you set up those defaults for the next person, they will follow along and things will stay the way they should be. Right about now, somebody usually tells me that their people are better than this. They don't need their hands held. They don't need to be protected. They would never add D6 and D7, so it's okay for me to add D1 through D5. This looks like a picture of a river, but it's actually a picture of a guardrail. It's probably the only guardrail in the entirety of the island nation of Vanuatu. If you don't know where Vanuatu is, it's relatively near Australia, and it used to be called the New Hebrides. I took this picture because I was so shocked at seeing a guardrail. Now, trust me, we were in the river before the picture, we were in the river after the picture, and there's a person in the river already. The guardrail doesn't keep you out of the river, but it keeps you from accidentally falling in the river. And the reason I was so happy to see it was where I had been the day before. I don't know this man, he was just further up the volcano than me. This is the volcano. I'm here, this is not a zoom, and over here is all the lava and everything. In fact, shortly after I took the picture, a lady came by in flip-flops and told me that I shouldn't stand right there because some lava had landed there earlier, and maybe I would like to go a little bit further up the volcano. If you haven't stood on the edge of a live volcano that throws lava and smoke and sulfur and rumbles every couple of minutes, you don't know what it's like to want a guardrail. This entire volcano was guardrail free. There were no signs, nothing. You feel safe standing there, you go ahead and stand there. Flip-flop lady might come by and suggest a different place. Like you can see the blobs of lava, right? No guardrails. So when I saw a guardrail, I was like, my God, it's a guardrail. And we took a picture. I enjoyed being on the volcano, but in my regular 9 to 5, 40 hours a week life, don't really want to stand on the edge of a volcano all the time. It's exciting, but it's not a regular existence. This guardrail isn't keeping anyone out of the river, and none of the things about writing simple code is going to keep you out of the river. In fact, you end up climbing in steps that have been carved in the rock and water's rushing over your feet. So it's a very temporary thing. But it gives you that little bit of a reassurance that you're going to be okay. And that's the kind of rules I'm talking about. Now, John, I told you I had a slide for you. I got this off the internet. I actually don't know what it does. But it says abstract and concrete all over it. There's two kinds of arrows because it's UML. And there's both dotted and solid lines, so somebody worked really hard, right? It does something. And when I was looking for it, I also found this great example of over-engineering. The example was in Java, and I translated it into C++. This code actually works. What it does is it creates an abstract factory. It's a horrible mishmash of raw and shared pointers because I was just trying to make it work. By calling on the singleton get instance and then calling get factory. So then I can make a subject by calling its create subject method, and then I can call create observer and pass that to subjects attach. Finally, I can create a command and pass that the subject. So now the command is connected through the observer to the subject. Then I can execute, and then it says hello world. Because there's only one observer, there's only one command, there's only one subject. It's not possible to do anything other than say hello world. And pre-building in that kind of flexibility in advance is one of the things we're a little bit famous for, right? We can change database vendors on a dime, or a tuppence, or whatever you change things on here. Who ever changed database vendors ever? Okay? Was the hard part changing your connection strings? Was that the tricky bit? I don't think so. The hard parts are the golf with the Oracle guy. That takes a lot of time. But that brings me to something that John alluded to earlier. Everything you do to code to make it simpler can actually make it more complicated. If you give everything a good name, does every single line of code have a 50-character name? And it's all in a one-line function? Every time you need any two variables to pass to anything, you gather them up into an abstraction so you're only passing one thing, right? You can totally overdo this stuff. And that's why it says wahaha on the slide about the simple rules, because it's not possible to write simple rules about how to write simple code unless those rules are very vague and full of judgment. I can't say 23 lines or 230 lines. I have to say short, good, usually. Now, it's tempting to say that this is because C++ is so darn complicated, but it is actually a law of the universe. Have you taught anyone to drive?
Yeah.
What speed should you drive at? Well, the speed limit. Oh, you just ran into a parked car. Okay, you should drive the speed limit unless someone in front of you is driving more slowly than that, in which case you should adjust to their speed. You just ran into a pedestrian. Okay, yeah, okay, anything on the road, adjust your speed accordingly, you know? You might end up with 10 or 20 rules just about your speed. Now, what lane should you be in? Again, you can't just say stay in your lane, right? Your lane could end. You could end up exiting when you didn't want to exit. All kinds of strange things could happen. There are no simple rules about driving. If you've seen the driver's handbooks, they're like this, right? And that's not counting all the nonsense about what the signs mean.
What's your position on self-driving cars?
The sooner the better, but I don't want to write the code. I mentioned I'm a new grandparent. Should I be asked, the baby is crying, what is the simple answer for what my daughter and son-in-law should do about that? Right? There's no simple answer for parenting. And the same is true when you're writing code. Should you use exceptions? Hint, the answer is not yes or no. Those are not good answers to that question. How long should functions be? What's a good name? Is it confusing to have a lot of parameters? Is it confusing to have overloads? Is it confusing to have defaults? These things are not yes or no questions. The answers to all of them are it depends. There are no simple rules for writing simple code because there are no simple rules for driving or parenting or any of the things that we do on this planet. But that was actually the easy part. Gave you a bunch of simple things that you can do where you exercise your judgment. You know where you get good judgment from experience and you get experience from bad judgment. So you hopefully write simple, but if you don't, you can come along and make it simpler. But there's a bigger story afoot. And that needs me to take a little bit of a detour. Do you remember doing this in school? Right? You take this binomial expression and you do first, outside, inside, last. You expand out the polynomials, and then you gather up the like terms, and there you go, you did a thing. And however big you were when you learned how to do that, you're probably pretty happy with yourself until the next week when they say, we're going to go the other way. And that was way harder. Now I have to come up with a pair of numbers that multiply to 4 and add to 4. 2 and 2 will work, right? But if they multiplied to 3 and added to 4, I'd have to come up with 3 and 1. And that recognizing the pattern and knowing some basic things to draw on quickly makes this a much harder job. It's not the simple mechanical of first, outside, inside, last. And that's the kind of thing that's much harder for you to do in your code, is recognizing, oh, I can use a thing with a name here. So I mentioned the ranged 4. You find a loop that touches every element in the collection. Maybe I should change it to a ranged 4. Or better still, maybe I should go look in algorithm. If you've seen the Sean Parent talk, where he first starts talking about algorithm, and he says, hilariously, this is obviously a rotate. And I was in a room full of really smart people, as we are today, and I'm looking around like, they don't think it's obvious, do they? It's not just me, is it? It was not obviously a rotate. But you want to get there. You want to be able to say, hey, this is obviously a rotate. Or stack, solved problem. Also, hate to break it to you, JSON parser, solved problem. I know you could write a JSON parser on the weekend because I've met like 5 people who each wrote a JSON parser on the weekend. You can find a JSON parser even quicker, right? Or a logger, or something that goes and gets stuff over HTTP, or what have you. I know it's hard, but other people's code is beautiful. What's more, if you write a JSON parser, when I come and read your code a year later, I have to go read your JSON parser code because I don't know if you did a good job or not. You probably did. I'm sure you're great. But I have to read it. But if you go and get one, I only have to Google it if I haven't already heard of it, and I'll find out if it's any good or not. So you're lowering everybody's cognitive burden when you say, I can use an abstraction from a library. But I mentioned we keep coming up with new idioms. Who's on the CPP Slack? That's a very small number of hands. I'll try to tweet out a link after the talk. You should be on the CPP Slack. Relatively high volume. This is on the free plan. All the history disappears every 3 days, so it's an ephemeral thing. It's like standing in a river. But people talk, and people come up with ideas. And as part of this Const all the things, someone came up with what they are calling, and do this right, the immediately invoked initializing lambda expression. You've got some variable that's a bit of a pain to get initialized, but once you get a value into it, it can be const. But you can't declare it as const because you've got to go through maybe plus equaling it or something, right? And the idea is if I call a function or a lambda, I can actually initialize it and let it be const from then on. That's a cool little idiom that we didn't used to have. Now it has a name. And if you've got a situation where the initialization process is what's making you avoid consting something, and you know about this idiom, you have a solved problem. But you have to know about this idiom. You have to keep up with what's going on. And so there are lots of initials in our language. There are lots of new idioms. There are lots of patterns. There are lots of conference talks. And knowing all that stuff and discussing it over adult beverages can just be a form of showing how smart you are, but it can also be a way that makes your code better. Can. I got this great for loop example from someone else. This looks relatively okay, right? Clearly a very smart person because they're using an unsigned 8-bit integer, so they must know about all the types, and they must be smarter than me. But the problem was that getSize returned a 16-bit unsigned integer, and so this loop did not stop. So what is the lesson? Lesson obvious is, wow, C++ is so complicated, like signed, unsigned, 8, 16, 32, you have to be so smart. And you know, I know a lot of people who are like, when they meet me, find out what I do, and I say I do C++, they're like, you must be really smart. This is like a farmer or someone who works in the grocery store. You must be really smart, because of all the programming languages in the universe, C++ is the one for the really smartest people. And I don't care for that. Because the correct response to this is not to memorize all the kinds of ints and fix this to take a 16-bit int. Right? The real solution to this problem is some kind of an abstraction, that collection. Like getSize, what is that? It's not a member function of anything. Why not? Why isn't there some collection? And then we can iterate over the collection. Maybe by calling begin and end, maybe by using arranged for, whatever, whatever. This I and this getSize have nothing to do with each other, and that's how their types got separated. When you make them have something to do with each other, it's less complicated because their types can't get separated. And that's a better thing than memorizing all the different kinds of integers and being that person who's always in code review complaining and saying, oh, but this actually returns 16 bits, blah, blah, blah. But it gets harder. So you've done the simple things, you've learned to recognize some old friends, but now, what does everybody actually know? Like, we don't want to surprise people, we don't want to wait what? So you know about an immediately invoked initializing lambda expression, but does the next person? Will they spot the round brackets hanging out at the end of the line? Because you say auto x equals lambda, 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 goes on for a while, whatever. Maybe you think x is a lambda, but it's not, right? Because there's a pair of parens out at the end of that line. X is at the type whatever the lambda returns. So maybe you're surprising someone when you do that. Maybe you're brilliant, but maybe you're too brilliant. So I'm going to put some weasel words in here. I want you to replace your complicated things with simple things, but they need to be familiar as well as expressing your intent. They need to be well known. Others need to be able to recognize them. If you're going to build in abstractions, they need to be abstractions that people can internalize and say, sure, I know what a purchase order is. They can learn it and remember what a connection does. Of course, you can't omit whatever the heck your program is supposed to do for a living, but you also can't become an architecture astronaut and hide everything behind all these abstractions and all this indirection. And you don't want to make changes hard in the future. You want to set everyone up for the pit of success. So global mutable state, that's easy. you suddenly realize there's an important piece of information missing on every screen. You're like, I'll slam in a global. Every screen can just look at it, and half the screens can change it. But you know that's going to be a misery later, right? In fact, this is where things get really hard, because you have to find a border. Am I skipping stuff to make it easy, or am I being elegant? Am I using a simple, well-known idiom to clearly express my intent, or am I showing how smart I am? And when you think you've got it right, and you show people, and it's really simple, it's only half a page long, and it says, open, process, clean up. And everybody can see that you open and then you process and then you clean up. And they go, is that all you got? You were gone for 6 weeks. That's what you did? That's a real thing. When you build that wooden statue with all the flowers and the caves and the doors and the clocks, clearly you worked very hard for a long time. When you make something simple, sometimes people don't recognize how much work that was. So you have to figure out how to make things as simple as possible, but no simpler. Speaking of misattributed quotes, apparently Einstein did not say this. He said a more complicated version of it, and somebody paraphrased it for him to this. I love that. But you know, no simpler. But you have to cite your simplicity in context. So today, this minute, typing a magic number, that's the simplest thing to do. 7. If x is greater than 7, whatever. But you know that over time, the truly simple thing to do is to set up some enum or some const or something so that the variables have names. People know what 7 means. And it's S-E-V-E-N is not appropriate as a name. John?
One out of quote.
Hmm?
Goldman Sachs quote,
Goldman-
long-term greedy.
Long-term greed?
Greedy, yes.
I like
Goldman
that.
Sachs.
I like that. Think about that long term. Don't take a short-term gain.
Yeah. Long-term
Take the
greedy.
long-term greed. I like that. I like that. Remember about the shorter letter. You have to take the time to write the shorter letter. The easy slam it in approach is not the simpler approach, but the simpler approach has that long-term benefit. And at one point I was going to call this talk the bravery of simplicity, because you're never quite sure. Did I write simple, didn't think it through? Or did I write simple, brilliant? And you have to stand up and show people you're simple, brilliant, and have them say, yeah, that's simple, brilliant. You know, somebody once said to me, that's some good engineering. I carried that around for a couple of weeks. You think you know the language. What if you forgot something? Right? What if you brilliantly learned constcast, got around all your const problems with constcast, get into code review, and someone says, why didn't you use mutable? And you go, what's mutable? Ow. This is also a real thing. I had a roommate in university, and at her job, they made hardware. I think it did things like figure out how far you jumped on water skis or something, I don't know. Anyway, there were chips involved, and one of the people scraped all the numbers off the backs of the chips, so nobody knew what was on the boards anymore. He felt that was job security. I think a lot of us write code for job security. If anybody can read your code and understand it and maintain it and add to it, why do I need you? Well, let me tell you, as someone who signs paychecks, I need people who write code like that. I would never, ever replace you with someone cheaper. Like, that's a really, really valuable skill. But it's easy to think that my complexity and my baroqueness and my sheer brilliance of difficult to read proves how smart I am is a great way to stay retained. So I ask you, does the code you write really reflect you and your abilities and just how far you are from being a beginner? So that you come back around full circle to writing code that's simple, that other people can read, understand, and maintain. So here's what I want you to do. I need you to learn. You need to know your language, you need to know your idioms, you need to know your libraries, you need to know what other people are doing. You need to try reading some code and figuring out what it does and saying, that was hard, or, oh, that's obvious. And figuring out what patterns actually are obscuring intent and what patterns are expressing intent. You need to care about the code you make. You need to care about the person who has to maintain this. You need to care about whether it'll still work 5 years from now when the government has changed the law 8 times. You need to test whether your code's really simple or not by showing it to other people. You know, you may think this IIILE thing is fantastic, but if you show the code to 10 people and only one of them sees those parens out at the end, maybe it's not so fantastic and you shouldn't adopt it after all. I can say that I really think RAII is going to catch on. I think you can go with that. And finally, you need to communicate. You need to communicate with your code as well as communicating in and about your code. If you do all of those things, you can get to some true simplicity, some hard simplicity, as far as possible as it can be from being a beginner. You'll definitely be writing better code. That's what I want you to do. Thank you. Put in a plug, Marshall.
All right, thank you. I'd like to put in a plug. Tomorrow morning, Jonathan Wakely and I are giving a talk with a very clickbaity subject called 10 tricks only standard library learners know. Come and learn some new idioms.
Oh, I like it. Learn new idioms. And if you don't follow me on Twitter, I can't find the home key on this thing. Here we go. No, that's apparently 7. There we go. There's my Twitter handle. There's my email. I will try to tweet the link to the C++ Slack, a great source of places to talk about code, questions, and watch idioms being born. There's some, you can also watch standards committee papers being born there as well. There's a lot of action happening on the Slack.
And if you see anything useful, make sure you save a copy of it because it will be gone in 2 days.
Absolutely. The thing about the Slack is it's on the free plan. There's a certain number of messages and they go away, and we hit that limit literally twice a week. All right? So if you see some way cool thing on the C++ Slack, which you will, like put a screenshot or copy and paste into some Word document, cool things I learned from the Slack, because it will not be there later. Okay? Well, I'm welcome to talk one-on-one if we have no more questions. Thanks for coming.